Chapter 4, Section 4, Graphing a Function Rule. To graph a function rule, you first make a table to find ordered pairs, and then you graph the ordered pairs. So when you're graphing a function rule, you're going to be given an equation or function rule, and you're going to be asked to graph it. You're going to make a table to show corresponding x and y or input and output values to form ordered pairs, and then you're going to graph the ordered pairs on a coordinate plane, and you will have graphed a function. The first example says, what is the graph of the function rule y equals -1/2 x plus 2? First, we need to make a table, and what I'm going to tell you that you need to do is you need to have at least, I'm going to say 5 points to graph. 2 of them need to be negative, 2 of them need to be positive, and generally speaking, you're going to want to plug in 0 for one of them. I have chosen to plug in the values -2, and I only plugged in 4. So, anyways, 4 will be okay, but I would prefer you to have 5. I said 5 and then I only did 4. So anyways, I would prefer you to have 5. I only did 4. So for these examples, you'll have 4. I chose -2, 0, 2, and 4. The reason why I chose those numbers is if you look at the function rule that they give us, y equals -1/2 x plus 2. I'm multiplying x by -1/2. Remember, multiplying by 1/2 is the same thing as dividing by 2. So I chose even numbers to plug in for x so that I didn't have to deal with decimals. It's always going to be easier if you look at the function and think, what would be easy numbers? Don't make it too difficult on yourself. Easy numbers to plug in for x, in this case, would be even numbers since I'm dividing by 2. So then you're going to plug in, first I'm going to plug in -2. If you have -1/2 plus -2, a negative times a negative is a positive, and 1/2 times 2 is 1. Positive 1 plus 2 will give you 3. When you plug in 0, anything times 0 is 0, plus 2 is 2. When you plug in 2, you're going to have -1/2 times a positive 2. So you have -1 plus 2 is going to be a positive 1. And then when you plug in 4, a -1/2 times a positive 4 will give you a -2 plus 2 is 0. Now that I have my corresponding x and y values are my ordered pairs, I have one ordered pair at -2, 3, another at 0, 2, another at 2, 1, and then one at 4, 0. Notice my dots are representing the ordered pairs, and then I've connected them with a straight line. So this would be an example of a linear function. The next example asks us, what is the graph of y equals x squared minus 1? Again, you're going to plug in, choose some x values. Here I've done 5. You're going to, again, 2 negative, a 0, and then 2 positive numbers. When you plug in, I chose -2, -1, 0, 1, and 2. In this case, it didn't really matter, but I do want to keep it in this graph, and then this graph is kind of small, so I chose some smaller numbers. You could have plugged in -3 and -4. It would have been not that big of a deal. And then 3 and 4. However, this graph, I'm kind of limited on the graph that I have on this slide. So when I plug in -2, now what's important here is when you plug in -2 for x, it would be -2 squared, which means -2 times -2. A negative times a negative is a positive, and 2 times 2 is 4. -1 is 3. A -1, -1 times -1 is positive 1, -1 is 0. When you plug in 0, 0 squared is 0, 0 minus 1 is -1. When you plug in 1, 1 squared is 1, -1 is 0. And when you plug in 2, 2 squared is 4, -1 is 3. I'm ready to plot these points and connect them. Notice that in this function, I have y equals x squared and then -1. Anytime you have x squared, you should get a graph that looks something like this. It's called a parabola. Anytime that you have an x squared and you are graphing, it should kind of look like a dip, kind of like a valley almost. That is what a function graph looks like when you have an x squared. So anytime you have an x squared, you should be thinking something like a parabola. Sometimes it's flipped over, so it kind of looks like a hill, depending on, we'll investigate later on when that happens. But it should be some sort of curved either U or a curved like hill kind of looking thing. But you're always going to choose x values and then find your corresponding y values to create ordered pairs that you can plot and graph on a coordinate plane. It says the graph of a real-world situation should only show points that make sense. So if you're given a situation and it tells you, for instance, Joe is going to go to the store and he is going to buy up to 10 gallons of milk. I don't know why he would need 10 gallons of milk, but let's just say. If you know that he is going to the store to buy 10 gallons of milk, up to 10 gallons of milk, we don't need to include numbers that are bigger than 10 because real life is saying he's going to go and he's going to buy up to. Now, we do need to include 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 because it says up to, so I'm not exactly sure how many gallons of milk he would be buying, but I know it's not going to be more than 10 because the real life situation tells me he's not going to buy more than 10 gallons. This example says the function c equals 12.5h plus 30 represents the total cost of renting a truck for h hours. What is a reasonable graph of the function given that the daily limit is 12 hours? Right here, a reasonable graph, this is a real life situation, it says the daily limit is 12 hours. If the daily limit is 12 hours, that means you are not going to be able to rent this truck for more than 12 hours. So in my graph, I don't need to include numbers that are greater than 12. I'm going to go ahead and make a graph. I have chosen 4 points and I've just spread them evenly from 0 to 12. So I have 0, 4, 8, and 12. When you plug in 0, 0 times 12.5 is 0 plus 30 is 30. When you plug in 4, 4 times 12.5 plus 30 is 80. Plug in 8 and you get 130, and plug in 12 and you get 180. Now I'm ready to go look at a graph, and I'm ready to plot my points on a graph and go ahead and connect them. Notice in all of these graphs, I've only gone up to 12 hours because I can't rent the truck for more than 12 hours, so I only need to include from 0 to 12. This would be a linear function. If you remember from the past couple of days when we've been talking about linear functions, it is a straight line. So just a reminder. When you're looking at continuous versus discrete, a continuous graph is a graph that is unbroken. So this would be an example of a continuous graph. I have my coordinate plane. On the graph, I have a straight line and there's no broken pieces. It is a continuous line. A discrete graph is composed of distinct isolated points. A discrete graph is going to look like this. So notice they are not connected in any way. They are just points that have been plotted on the coordinate plane. They do have a relationship to each other, but we can't draw a line through them. So continuous, there's going to be a line going through it. Discrete, it's just going to be points that are not connected. This example says Megan buys eggs at the supermarket for $1.75 per carton. The cost is a function of the number of cartons bought. What is the graph of the function? Is the function continuous or discrete? Well, you can see that I've accidentally already have this graph up, but if you think about going to a supermarket and buying cartons of eggs, they're not going to let you go in and say, I want a carton and I'll only take 2 eggs from this carton, so I have a carton plus 2. That's not the way that it works at the supermarket. You're either going to buy 1 carton, 2 cartons, 3 cartons, or 4 cartons. There's no in between. You're not going to be able to buy 1.5 cartons or 1 3/4 cartons of eggs. So in this case, it would be a discrete graph because you have to buy a whole carton. To find the cartons and the price, if you buy 0 cartons, you're not going to have to pay anything. Okay? If you buy 1 carton, you would have to pay $1.75. If you bought 2 cartons, it would be $3.50, and if you bought 3 cartons, it would be $5.25. So notice I've already plotted those points on the graph that's shown. I am not going to connect them because it is not a continuous function, it is a discrete function, because I cannot buy between 0 and 1 cartons of eggs. So those numbers between 0 and 1 aren't going to apply. But 0, I can buy 0 cartons, I can buy 1 carton, 2 cartons, 3 cartons, and so on. I could buy as many cartons as I want. Today's assignment is on page 274. It's numbers 2 through 34 even and 42 through 52 even.